Now we're going to create the loads. Double-click on the loads item. Let's name our load force pulse. It's going to be applied in the loading step, and it's a concentrated force. Recall that when we created the loading step, we gave it a time of 0.01 seconds. So that means our concentrated force will be applied to the truss structure for 0.01 seconds. Abaqus prompts you to select the points for the load. Notice the button Sets at the bottom right corner of the viewport. Since we've defined sets, we don't need to click on the node in the viewport. Rather, we can just click on the Sets button and pull up the set that we've already defined. Select Force Point Set. You can check off Highlight Selections in Viewport just to make sure you are selecting the correct set. And you see the force point node light up in red on the viewport in the background. Click Continue. In the Edit Load window, set CF2 to -600. CF2 is the force in the y direction, and our force will be applied downward, so that's a negative y direction. So we're applying 600 newtons in the negative y direction. Click OK. You see the force applied in our model. The boundary conditions are the same as the ones used in the static truss analysis. Double-click Boundary Conditions, set the name to Pin, and apply it in the initial step. This is going to be a mechanical boundary condition, and choose Displacement Rotation. Since we'd use steps to select our load points, Abaqus assumes that you're also going to select sets for your boundary conditions. However, we haven't created sets for the boundary conditions. We plan to just select them in the viewport. So click on the button titled Select in Viewport at the bottom right corner of the viewport. Hold down the Shift key and click to select both nodes. In the Edit Boundary Condition window, we're going to constrain translation in the 1 and 2 or X and Y directions, but we're going to allow rotations, thus giving us a pin joint. We use the same meshing procedure as we did for the static truss analysis. We create the mesh on the part itself. We set the element type to a 2-node linear 2D truss. We seed the edges by number, assigning 1 seed to each truss member. And then we go ahead and mesh the part. Now we're ready for an analysis. We create a job called Truss Explicit Analysis Job. We give it a description and set it to run a full analysis. We then right-click on Truss Explicit Analysis Job and choose Submit to run the job. Once the job is completed running, we right-click on it and choose Results. You are now in the Visualization module. To view the history outputs, go to the Results menu and choose History Outputs. You see that U1, which is displacement in the X direction, has been saved for the force point set and the endpoint set, and the same can be set for U2, which is displacement in the Y direction. Therefore, you have 4 sets of history output. Let's plot the Y displacement of the endpoint set. Choose Spatial Displacement U2 in nset endpoint set and click on plot. You see a plot of displacement with respect to time. Notice that the time is 0.01 seconds because that was the duration we set for the loading step. We also indicated when creating the history output that we would like it saved for the loading step. We'd like to save the data for this plot, so click on the Save As button. Let's name it Data for Endpoint, and click OK. Abacus creates an XY data object. Similarly, we can plot the Y displacement for the force point set, and we can save that as data for force point. Click Dismiss to close the window. Now that we saved both the plots as XY data, we can put them in a report. Go to the Report menu and choose XY. In the Select From option, choose All XY Data. This displays a list of XY data that we have gathered so far. You see that data for endpoint and data for force point have both been listed there, since we only just saved both those plots as XY data. Choose Data for Endpoint, then go to the Setup tab. Here we set a name for our output file. I'm going to call it endpoint xydata output.txt, which is a text file. And I'm going to uncheck the Append to File option so that if this file already exists, we're not going to be appending to it. Abacus is going to delete it and replace it with the new file. In the Data section, for Write, check XY data, columns totals, and columns min-max. Switch back to the XY data tab. Make sure Data for Endpoint is selected. Click Apply. In my case, I had already created this file before. Abacus is prompting me to overwrite it since I unchecked the Append to File option. So I'm going to go ahead and click Yes. You notice at the bottom of your screen, Abacus tells you the XY report was written to file. Repeat the process for the force point data. In this case, name the file forcepointxydata output.txt. And be sure to hit Apply to write the output file. And click OK to close the window.